Hi everyone, this is F8EVM Istanbul Hub, an educational repository built for the Zama Party Track December 2025. The goal of this project is to provide minimal self-contained F8EVM examples that demonstrate privacy-preserving smart contract patterns using fully homomorphic encryption on Zama's confidential blockchain. Each example focuses on a single concept and is designed to be easy to run, easy to read, and safe by construction. The repository is organized into four main parts. First, base template, which is a reserved clone of the official Zama F8EVM hard hat template. All examples are generated from this page to keep configuration and tooling consistent. Second, docs, which contains auto-generated documentation built from example readmes and chapter text. This folder is fully generated and not edited manually. Third, examples with host standalone hard projects grouped by concept such as basic encryption, asset control, advanced patterns, and open Zeppelin confidential examples. And finally, scripts, which provides lightweight automation for scaffolding examples, generating docs, and keeping everything in sync as dependencies evolve. Each example is completely standalone. You can simply enter the directory, install dependencies, and run tests. This basic example demonstrates how encrypted values are created off-chain, validated with input groups, and handled safely on-chain without decryption. Most examples run on the F8EVM mark to ensure fast and deterministic stating. This is the most advanced example in the repository, encrypted treasure chest. It demonstrates encrypted threshold-based asset control. A player starts a session and must collect approvals from 3 out of 4 guardians. The important part is that approval counts are encrypted. The contract never branches or reversed on encrypted values. Guardian signs approvals obtained using EIP712. Unlocking the chest gets the encrypted loot output without revealing whether the threshold was met on-chain. This pattern models real-world privacy-preserving workflows like confidential multi-sig or gated authorization. This category demonstrates interaction with Open Zeppelin confidential contracts. The ERC7984 example shows a minimal confidential fungible token, where balances and transfers remain encrypted, and only authorized users can decrypt handles off-chain. The confidential vetting wallet demonstrates encrypted vetting logic, time is plain text, but allocations and vetted amounts remain encrypted. Instead of reverting based on encrypted conditions, the contract uses gated outputs, returning encrypted zero when nothing is claimable. Whole examples intentionally avoid Delphi or swap logic to keep the focus on core confidential patterns. One important part of this repository is how new examples are created. Instead of copying folders manually, new examples are generated using a small CLI tool. Here I create a new example called symbol FSE counter test. The tool copies the set-based template, inject example-specific contrast text and readme, and patches the packet metadata automatically. This ensures that all examples stay consistent and makes it easy to update or regenerate them when the FSEVM template or dependencies change. This approach allows the example hub to scale without manually maintaining overhead. The documentation generator scans example readmes and produces Gitbook-compatible docs. The validation scripts ensures every example has a readme with a chapter tab, plus contrast and text. Additional tools like dependency pooling and base template scenes make it easy to update all examples when upstream versions change. To summarize, this repository is an educational FSEVM example hub designed to teach correct privacy-preserving smart contract patterns. It avoids common FSE anti-patterns, keeps examples minimal, and focuses on long-term maintainability. Thanks for reviewing this submission. Thank you.